We want to prove or verify that secant of theta divided by cosine of theta minus tangent of theta divided by cotangent of theta is equal to 1. So to verify or prove an identity, we're going to imagine that there is a brick wall between the left side of the equation and the right side of the equation, and we cannot cross over that brick wall. We're trying to make the left side of our equation look like the right side of our equation, and we can't do things like you can do in a normal equation, like multiply by the same factor on both sides or add the same thing to both sides. We're trying to prove that the two sides are equal, so we have to work with them independently. So to start out with, I'm going to take secant of theta, and note that cosine is the same thing as 1 divided by secant. That's one of our fundamental identities. So I'm going to rewrite that. And when I do that, secant divided by 1 over secant, if when you're dividing with fractions, you flip and multiply by the reciprocal of the denominator, that's going to give me secant of theta times secant of theta, which is secant squared theta. And for the next part of my equation, I have tangent of theta divided by cotangent of theta, and cotangent is the same thing as 1 divided by tangent, using, again, a fundamental identity. And so similar to what happened with the other term, tangent divided by 1 over tangent, when we flip and multiply by the reciprocal, is going to give me tangent times tangent. And so tangent times tangent is going to be tangent squared. And that is one of our fundamental identities. Secant squared minus tangent squared. A secant squared is a 1 plus a tangent squared minus a tangent squared. If we collect like terms, the tangent squareds are going to cancel out, and we end up with 1. The left side is equal to 1. The right side is equal to 1. So we have proved that identity.